rates a little bit higher, they're a little bit lower in their frequency. And finally, SNPs, which we can measure their mutation rate by looking at antibiotic resistance in a neutral model, mutate very slowly, maybe only 10 to the 9th, minus 9th, 10 to the minus 10th per locus per generation. But the great news is the genome's big. These genomes range from 3 to 8 megabases. And so in fact, in almost all the bacteria that we study, if you focus in on SNPs and you have whole genome sequences, you can find a SNP here about as often as you can find a mutation over in the VNTR, at least within an order of magnitude. And in some cases, it's actually higher. And the advantage again is that you end up with very low homoplazy in the SNPs, because in a neutral model, it's highly improbable that any single SNP will mutate in these very young populations. Okay, so the first disease I'm going to tell you about is caused by Burkholderia pseudomallei. And this is the slide for forest, because this is the habitat of this organism. So this bacterium lives in the water. This is a rice paddy in Thailand, taken by one of my colleagues, Abhishai Twanyo. And this blue is like an origin. We have bacteria in here, we have phage in here, and they're just exchanging DNA like crazy. So this is the equivalent of a sex shop, but with productive products. You know, you can see some of the major players here. Of course, we have a plant back here, we have this rice farmer, and we have this water buffalo. This is a big black box to us. When we go in and do microbiome studies on this by looking at 16S, we can sequence pretty deeply and never actually see Burkholderia pseudomallei, and yet we can go to a field and we can do selection for this particular type of bacterium by using a selective medium, and we can discover it. In fact, you can take 10 mils of water out of here and get an almost confluent petri dish. So it's a minor component, but it's very present if you have the selection. And unfortunately, sometimes this selection is the farmer himself. This is the disease that gets into people. When it gets into people, it can go by different routes. It can go through abrasions to the skin. It can be inhaled. You can eat it. It's manifested as sepsis or as abscesses or even as urinary tract infections. And so it's called the great mimicker because it looks like a lot of different diseases. So this bacteria is not clonal. It exchanges DNA at a very, very high rate. Now, here are the hotspots for it, and this geography is really important because I'm going to tell you about our phylogenetic analysis of this in just a second. But it's found in the upper end of Australia. Basically, it's found worldwide along plus or minus around the equator, even Ecuador. And in fact, I'm not sure if it's ever been discovered in the Galapagos. That may have got colored just because Ecuador got colored in the